Let's take a look at technologies that deal with multiple antennas. There are a couple of them that we want to look at particularly. And if you look at a wireless router today, you'll probably see a lot of antennas on them, maybe 8 different antennas, for example. Well, the technologies that are using are one of two main ones, either MIMO, which means multi-in, multi-out. This mathematically combines multipath signals. Let me explain multipath signals. When something travels from one place to another, it arrives at different antennas at different times here. Not only because of the travel distance from one antenna to another, but also, and it doesn't show it here, also because it's bouncing off the ceiling and it's bouncing off the floor and it's bouncing off the walls and it's bouncing off other objects. And so because it's bouncing off all these things, it's getting these reflected signals over here at the other antenna. Imagine that you only have one antenna here. Well, even though you have a straight line between this antenna, the signals aren't going straight. Right? This signal is coming down here. It's probably going to hit a wall or a floor and then be bouncing up. So it's going to get a whole echo of signals at different times. And the idea of MIMO, or multi-in, multi-out, is that it's going to mathematically put all that back together and get a better signal, because it's going to be able to fill in the gaps, so to speak, when it has corrupt packets coming in. It'll fill in the gaps and be able to figure out what that packet was supposed to be and not have to retransmit. So that's the idea of MIMO. Now we have something even newer than that called MU-MIMO. This means multi-user MIMO, multi-user, multi-in, multi-out. This idea is that you have multiple antennas here, and each antenna, or I should say each set of antennas, is going to another device. So, for example, I have an antenna here going to the phone, one going to the laptop, another one to another phone, another one to another laptop, and I can serve multiple devices all at the same time. So essentially, this is like multiple routers, if you will, although they're all operating on the same SSID. So that's MU-MIMO. Sometimes you'll see SU-MIMO as well, and that just means single user MIMO, and that would be the same as MIMO. Let's look at encoding techniques. So we have these waves. Now, waves don't occur in blocks like we saw earlier up here. We saw these blocks. We have to convert them. And so that's what our digitization does. We convert them from these analog signals to these digital signals. And as we convert them to the digital signals, we also are encoding ones and zeros depending on where the ups and downs are, and the whatever system that we're using. And there are various mathematical systems that we use to do that. So we encode waves by varying two different properties, actually three. I didn't include one of them here. Amplitude modulation, and that is where we just change the amplitude, and so we can say that maybe the high amplitude ones are ones and the low amplitude ones are zeros. So that would be one way of encoding this. And by the way, of course, you're familiar with AM radio. That's exactly how AM radio works, except it's not digitizing it. FM is just changing the frequency. So here we have the frequency. Here we have a longer wavelength or lower frequency, and here we have a high frequency, and a low frequency, a higher frequency, mid-range, and so on. And so by changing the frequency, we can encode ones and zeros. We also have one, by the way, called phase, and I didn't put that one in here. I should have. Phase modulation. The idea of phase modulation, actually you can see it down in this one. You can see that right here. Let's see if I can see the shift in phase here. Oh yeah, here's a shift in phase. So I can change the phase all of a sudden. In other words, where the ups and downs are in here, I can change the direction of those, and I can also modulate that way. And for some reason I left that out of here. I also don't think the book talked about phase modulation. QAM is actually a way of modulating using all of those, frequency, amplitude, and phase modulation. And so by doing that, we can actually get 4 times the amount of data in the same number of swings of the phases or swings of the signal here. By the way, there are several versions of QAM. We can have an 8 QAM, 16, 24, 32, 64, 128, and 256 QAM, and on. You can actually go up 1024 and so on. 512, 1024. And the only problem with that is the higher you get, the less reliable it is. The more data it can carry, but the more susceptible it is to noise and loss of signal. But with each of these, you can double from 8 to 16, for example, or from 16 to 32. You can double the amount of data that you can fit into the same number of swings of the phase here, or swings of the signal. So that's QAM. Don't try to understand QAM, just realize that it's a combining of amplitude and frequency and phase modulation. All right, we're going to cut that off here. We're going to start hitting these Wi-Fi standards next time, and we have a bunch of information to talk about on those, so we'll hit that one up in the next video.